So good morning, everyone, and welcome to day 2 of our Imagery and Remote Sensing webinar series. I am Samkit Bagmar. I contribute to the Imagery and Drone Solutions business here at Esri India. So it's wonderful to see you all here. So many registrations, so many people have returned from yesterday, along with a warm welcome to everyone joining us for the first time today. So whether you are working with satellite imagery, drone images, video frames, radar pulses, all of you are here, and we are thrilled to have you all here. So yesterday we kickstarted the webinar series by diving into Geo AI and exploring how artificial intelligence is helping feature extractions or image processing and making your productivity 10x faster for the people working with ArcGIS. But as many of you know, desktop analysis is often just a step one, right? So many organizations are dealing with massive volumes of spatial data coming from multiple sensors, sources, right, every day. So the real challenge isn't just analyzing those images on local workstations, it is scaling those workflows so that the analysts, field teams, decision makers, right? So all these people across the organization can access and act on those insights in real time. So this is exactly what today's session is all about. So we'll be moving from individual image analysis to enterprise grade intelligence solutions. In today's session, pixels, pulses, frames for image analysis to enterprise intelligence, we are going to look at functionalities of ArcGIS Pro Image Analyst and ArcGIS Enterprise Image Server and how they can work together as an integrated end-to-end system. So we'll be covering how to manage and process diverse data types, right from optical imagery, multispectral, hyperspectral, video frames, and SAR imagery as well. We'll also see how to move your local desktop analytic workflows seamlessly into enterprise environment so that various stakeholders from within your organization and beyond your organizations can work together. We'll also see how to serve dynamic imagery services, run web-based spatial analysis, and collaborate effectively between those teams that you work with. Now, again, as a reminder, so today's session will run for about 90 minutes, right? Giving plenty of time to live technical demonstrations, workflow breakthroughs, and an extended Q&A session at the end. Although we started late, we'll try to pick it up and cover it within the time, right? But we are also excited to show you a lot many new things that have come up. So to guide us through today's deep dive, I'm delighted to introduce our expert presenters, right? Ishita Monga and Abhishek Yadav. So both of them are part of our imagery team at Esri India. Both of them are helping enterprises scale, structure, and automate their imagery architectures. And today they will walk you through practical workflows you can apply directly within your own organization. So quick housekeeping. As always, if you have any questions during the presentation, please feel free to type them in the Q&A box at any time. We will track those and cover as many questions as possible towards the end of it. Do not hold your questions. It doesn't matter how silly you might think it is. It could be beneficial for many others who are attending it. Right? So do not hesitate to write those questions to us. So without any further delay, let's get started. Ishita, over to you.
Thank you, Samkit, for the introduction. So here's a quick overview of today's webinar. So first we'll move on to the basic image processing and advanced image processing, followed by the image management and sharing and image analytics, where we can learn about the various toolboxes and assessing the stacked catalogs, SAR image analytics, and browser-based image and video analysis, followed by scaling raster analytics. So ArcGIS provides a complete imagery ecosystem which supports the entire workflow from reality mapping to analysis, visualization, and data management. So it enables the users to generate high imagery products from AI-powered image analysis such as classification, change detection, visualization of the results in 2-dimension as well as the 3-dimension, and efficiently manage and share imagery at scale. In this webinar, we'll focus on the image analysis capabilities available in the ArcGIS Pro. So ArcGIS supports virtually every type of imagery from multispectral to the categorical rasters. We have the elevation imagery, trajectory imagery. Just to give a brief about the trajectory imagery. So trajectory image is a visualization between movement path of an object over time by comparing it at different timestamps into a single image. For example, it can be used for cyclone tracking. And we provide cloud and stack agnostic technologies which allow seamless access to imagery from all the sources such as ArcGIS Living Atlas, AWS, Earth Cloud Data, Microsoft Planetary Computer. This flexibility enables the users to work with diverse datasets in a single integrated environment. ArcGIS provides a comprehensive image analysis system that transforms this raw imagery into actionable insights. It supports a wide range of workflows, which includes the spectral analysis, image classification, machine learning, multidimensional analysis, suitability analysis, distance modeling, terrain analysis. These capabilities are available across ArcPro, ArcGIS Enterprise, Arc Online, and APIs, which enables the organizations to follow real-world challenges such as disaster response, asset monitoring, environmental management, and infrastructure planning. Just to give a brief overview of the tools available, so there are hundreds of tools in the image analyst, raster, and spatial analyst toolbox. And the point to note here is that these all tools are supported for parallel processing and model builder, where users can automate the workflows, improve the performance, and efficiently process large imagery datasets. Now coming on to the most widely used tool of ArcGIS Pro, the image classification workflow. So this workflow provides the image segmentation and training sample creation to classification and accuracy assessment. It supports a variety of machine learning algorithms like random trees, support vector machine, K, nearest neighbor, and maximum likelihood, which enables the users to generate reliable land use land cover map and thematic map products. Now coming on to change detection. So change detection is one of the most powerful capabilities of ArcGIS Pro, which enables us to identify where, what, and when the changes have occurred. So it supports both image to image comparison using the pixel, spectral, categorical, and deep learning based methods, as well as the image time series analysis using the algorithms like Land Trender, CCDC, which are to monitor the changes over time. These workflows have multiple applications such as urban expansion, deforestation, disaster assessment, and mining monitoring. Now I will be demonstrating the classification and decadal change analysis for Hyderabad region. Right. So for the present analysis, is it visible? No. I need to share it. I need to share it. Right. Sorry for the delay. I hope it is visible now. Extremely sorry for the delay. Is it visible now? Right. Yeah. So I have used the Sentinel-2 imagery for Hyderabad region to detect the decadal change analysis from the year 2015 to the year 2025. This is the imagery which I use for the analysis, and this is my region of interest. So, in order to classify the image, first we'll go to the classification wizard. And here we have both the option of supervised as well as unsupervised classification. So for this analysis, I have chosen supervised classification. And here we have the type for classification that can be pixel based as well as the object based. For the schema, we can choose the default schema, or we can give a schema according to our own needs. And then we can further, like for example, for this analysis, if I use the default schema, then we can go to the segmentation. So this segmentation allows is also automatically allows the thresholding of the image. Then we can proceed to the classification. So basically, this is the schema which was decided before. So here I can give the training samples for one of the classes, and I can proceed with the classification using these training samples. For example, for water, if I give training sample like this, for all the classes, the training sample is provided. Now we can choose the classifier. Like for example, there are various algorithms available for classification, like maximum likelihood random tree, support vector machine, k-means number. For this analysis, I chose support vector machine, and this is the output which I got. This is the classified output. Once the classification gets completed, we can use this output in the change detection wizard to further detect the change based on the classified image. So when this classified output is inputted inside the change detection wizard, for land use land cover classification, we can go for categorical change as it has already been classified into various classes. So the from raster will be the previous raster which were classified. So for the year of 2015, to raster shows the later classified image, that is 2025. You can choose the processing extent to the classified image. And here the software allows you to choose the filter method to all, changed only or unchanged only. And here you can detect the change from certain classes to certain classes if the area of interest is varied. Like for example, if I only want to choose detect the change from built up to built up, then I can choose the classes like that and click on next. So this is how the change detection would look like. And here I would like to give you this overview of the various thematic layers which have been classified. Like for example, like this, the change has been classified from the classes to various classes using the change detection wizard, and these are the classified outputs which we got before. So here I would like you to just quickly focus on some of the regions. Like for example, this Bachupalli region, here we can see that it has visibly changed from agriculture to built up. So like this, the urban expansion has occurred in the Hyderabad region. And like for example, in this region, Kutubulapur, you can see that again the land use land cover has changed from agriculture to built up. So like this, we can analyze the image using the classification wizard as well as the change detection toolbar. Coming back to my presentation. Right. So now I'll be talking about the multidimensional raster analysis. So ArcGIS Pro provides powerful tools for analyzing multidimensional raster datasets like time series satellite imagery, climate data, and weather observations. So what it does, it enables users to aggregate the data, detect anomalies, perform trend and predictive analysis, and identify the spatial and the temporal capabilities. So now image analysis using charts. So charts such as histograms, spectral profiles, spectral plots, temporal profiles, and time series explorer provide valuable insights into the pixel behaviors, spectral characteristics, and changes of over the time. So these tools they support the faster interpretation and improve the analysis accuracy and aid in selecting the right parameters for the image processing workflow. Coming on to the spectral analysis tools in ArcGIS Pro. So using these spectral analysis tools, we can analyze spectral signatures. We can even integrate field collected spectral libraries, perform spectral-based classification, and detect spectral anomalies to identify specific materials or features. These capabilities are especially useful for applications in mineral exploration, agriculture, vegetation, health assessment, and environmental monitoring. Now, for hyperspectral imagery analysis, the sensor support in ArcGIS Pro is refers to the sensors such as Everest, Dragonet, Emmet, Nmap, Hyperion, PACE, and Tanager. And it includes various tool sets such as the spectral library browsers, spectral signature viewer, linear spectral unmixing method, classifying raster using spectra, and detecting image anomalies. These capabilities are useful in various tools. Now I will proceed to the demonstration wherein I will identify the minerals from hyperspectral imagery using image analyst in ArcGIS. Right. So now looking at the ingestion of the imagery. So first we'll add the data using add data and hyperspectral data. In the current analysis, I have used the data set from Planet. This is the Tanager sensor data, and it has been ortho rectified. And so like this, we can ingest the data, and it has identified all the products which are available, and the band selection method is also available. So like this, we can ingest the data, and this is how the data set will look like. So this is the Tanager imagery. And as you can see, there are varied number of bands since it is a hyperspectral imagery. So we have 426 bands here, and we have successfully ingested this image. Now, moving on to the further analysis. So in hyperspectral imagery, the dimensionality of the image needs to be reduced for further analysis. So for that, we need to run the principal component analysis, which is again a capability within ArcGIS Pro. So here we can simply use the geoprocessing toolbar and use the principal component. So principal components will reduce the dimensionality of the image and remove the band for further analysis. So like this, we can input the surface reflectance image which is present. And by default, it will take the number of principal components as the total number of bands available in the image. So for mineral analysis, a total of 6 bands, 5 to 6 bands are enough for the analysis. So like this, we can get the number of principal bands and run the tool. And this is how the output will look like for this. Now the pre-processing has been done. Now we can look on to how we can do the particular analysis and identify particular areas of interest. Like for example, if I want to highlight certain areas related to geologically important regions like iron oxide, ferrous minerals, or clay metals, then I can click on the indices and choose one of the indices. So like that, if I want to view the iron oxide reflectance in this particular imagery, so this is how the output will look like. Here, the highlighted regions in red will is giving that the indices of iron oxide is more here. So the probability of finding iron oxide is more in this as compared to the other regions in the image. So like this, you can highlight particular area of interest in the hyperspectral image. Now coming on to the spectral analysis part. So using this pre-processed data, now we will proceed with the spectral analysis. So this spectral analysis toolbox offers us a various variety of tool sets which are required for this analysis. First will be the spectral signature viewer. So using this spectral signature viewer, what we can do is we can view the various spectral signatures within this particular imagery on the fly. For example, if I want to view particular signatures at this point in this imagery, so what I'll do is I click on this point and like this, it will give me the spectra signature using the hyperspectral image. Now, once I have decided my area of interest, then I will need to compare it with the standard spectral library. For that, we have the resource, we have the tool for Open Spectral Library. So this is the Open Spectral Library browser, wherein we can ingest our own spectral library, or we can use the standard spectral library, which is present in the ArcGIS for further analysis. Like this, we can ingest the spectral library, and now we need to compare this signature with a standardized signature. So for that, for example, if I want to compare it with the signature of albite mineral, so I'll just click on the albite and I will add it into the signature view. And I will compare this signature alongside the signature of the mineral. And like this, I can create my own spectra signature file and I can save it for further use. So now this spectra will be used for the target detection in the image. So for this, we can use the target detection wizard where we can input our image, we can subset our bands, and we can give the processing extent. Here we can save our target spectra signature and we can, for example, input the target spectra and run this. It offers a lot of methods for classification like SAM, SID, NS3, ACE, CEM, and NF for computing the matching scores for the product. So this is the way how we can analyze the hyperspectral data within ArcGIS. So moving forward for raster functions. So raster functions in ArcGIS Pro enables on-the-fly image processing, which are now allows you to analyze imagery without creating immediate data sets and save both the time and the storage. So there are about 160 built-in functions and raster function editor, which the users can build reusable processing chains and save them as template and share them across the ArcGIS platforms. This makes raster analysis faster, scalable, and easy to automate. Here, I will give a brief demonstration on acid mine drainage detection using raster function text. So first, we'll talk about the ingestion of the data. So again, add data, go to the hyperspectral data. And here for this analysis, I have used emit data. So emit data for this Rajarappa mines region. And the data looks something like this. So for this particular analysis, I have used raster function. These raster functions can be downloaded directly from ArcGIS Living Atlas, and there is an option to customize these as well as use them the predefined models which are present within the raster function. So the custom for this particular analysis, I have used this acid mine drainage raster function template which is available. And like this, you can see the model is visible here. And it is as simple as running this model to get the results for acid mine drainage. So this analysis was performed for Rajarappa mines in Jharkhand. And these are the results which we got in this analysis. So this analysis shows that the Damodar River basin got severely affected due to acid mine drainage, as there are deposits present within the river valley. And carbonates were also detected in the open mine in the region. And these are the various minerals which were found within this region. So like this, the raster template has given the various points where the effect has been given. And this is the buffer zone of the affected region for which was affected by this acid mine drainage. And we further use the socio-economic data of Jharkhand to demonstrate that how much of the population got affected due to this phenomena. So like this, you can visualize like this was the population which got affected due to this acid mine drainage. So like this, we can use it for other mines as well. So we did for Khetri mine, Rajasthan as well, the same analysis. And these were the affected points which were found there. These are the points. And again, similarly, the buffer was created for the affected points. And we got to know which all population got affected due to this. Right. So now ArcGIS provides comprehensive SAR analysis capabilities with support for sensors such as Sentinel-1, ISI, RCM, Radar-Sat2, Capella, and NISAR. It includes tools for pre-processing, radiometric and terrain correction, coherence generation, water extraction, and feature detection. And so these capabilities enable applications such as flood mapping, oil spill detection, ship detection, and disaster monitoring, making SAR an invaluable data source in all weather and day-night conditions. So now I will be showing a quick demonstration on water body extraction using SAR data for Hirakud. Right. So I hope that my screen is visible. And this is my area of interest. This is the Hirakud reservoir. And this is the SAR data for the reservoir. For the data set which I have used is Sentinel-1 Imagery for 2025. And so I have performed various pre-processing steps first for the analysis. So like this, in the geoprocessing toolbox, there are varied tool sets available for synthetic aperture radar. And like this, we can, for water body extraction, we first need to pre-process the data. In order to pre-process the data, I have used tool sets such as downloading the orbit correction file, applying orbit correction, applying the radiometric calibration, and applying this geometric terrain correction, despeckle, and then finally I have used the tool to convert it into SAR units. So like that, I have used two tiles for this analysis covering the Hirakud reservoir. I have mosaicked the two tiles. For this particular reservoir. And then, so I will just give a brief about how to mosaic the tiles. So basically, what we can do is using the database, I have created a mosaic data set in this database by going to new and mosaic data set. And like this, I have added the two tiles into the mosaic data set and thereby creating this mosaic data set of this area of interest. This is followed by thresholding for the water extraction of this Hirakud reservoir. So basically, based on the values of obtained after converting it to SAR units, I have used the raster calculator to create a threshold to extract the water of this particular region. So after thresholding, this is how the result will look like, and this is how the water was extracted from this particular SAR image. Just to give you a brief about the importance of this is that the water body extraction using this tool, we can further proceed on to delineating the change in particular volume and of the water body for pre-monsoon and post-monsoon. So this is how the result will look like, and this is the extracted water body after doing all the pre-processing and thresholding using raster. Coming back to my slide. Yeah. So next demonstration is yeah. Next demonstration is ocean wind extraction using SAR data for Gulf of Cambodge. So like you may not, most of the people may not know that we can do ocean wind extraction using SAR data as well using ArcGIS. So I would quickly move on to my demonstration. So like we did before, so first we need to pre-process this SAR data. So like that, I have again done all the pre-processing steps like doing the radiometric calibration for this particular, downloading the orbit file, applying the orbit correction, doing the radiometric calibration for this particular region. And then I have used the extract ocean wind, ocean speed, ocean wind tool in the image analyst, and I have and we have used the corrected radar data, and this is how its output will look like. So like this, it not only shows us the wind direction as well as the speed of the wind in various in the particular region. So like this, we can use the SAR imagery for ocean wind extraction. So now I will hand over this webinar to Abhishek for further discussion. Thank you.
Thank you, Ishita, for the brief demonstration. That was a wonderful session we had all together. I'm sure that we all must have enjoyed this session all through. So coming to my portion, I'll take just 2 minutes to give a brief about what I am going to demonstrate and what you can expect from my session. So when we fundamentally talk about image processing, the very first and fundamental step is image acquisition. And in today's world, when we look over the when we look in the geospatial domain, there is large scale of data set coming all around. Every minute we are being poured with high resolution optical data set, very good SAR sensors, multiple band SAR sensor data is being captured. Aerial platforms are capturing high resolution imagery, and there are independent and autonomous drone fleets as well who are pouring us with pixels. So having this much image, still many agencies, many organizations, institutions, and individual analysts feel a stark contrast between data acquisition, data management, and ready to analyze analytics steps. So what we offer here, what we see here, we see major problems in accessing the data where many organizations face a bottleneck in order to access the data set. The data is stored in different servers, in different on different cloud platforms, or in different containerized Kubernetes. This creates a dependency and delays the process of acquisition. And in scenarios like disaster management, in scenarios like defense, and in highly critical and vulnerable situations, this delays the analytics, which in further delays the decision-making process altogether. And having data set on individual machines, let's say on a containerized and isolated server, it also reduces this scalable analytics, which we can do using the capability of the different models and modules which are being available in today's world. So what is the solution to this? In ArcGIS, we provide raster models where you can provide a structure to your data, where you can create mosaic data sets and combine hundreds of proprietary files, different raster formats into a single structure where you can call any of your data set using the metadata from a seamless infrastructure. These data sets could be multidimensional data where they have time series data for moisture, rainfall, etc. And these could be trajectory data set as well, like Ishita already mentioned. That these data set contains information for ocean bathymetry, altimetry, etc. So having raster model like mosaic dataset, you can call on these dataset on the fly and do the analytics on simple clicks. The beauty of these mosaic dataset is that it creates a seamless raster surface where pan sharpening, mosaicing, and orthorectification happens on the visible scene and does not run on the whole image tile. So the processing speed gets optimized and you get analysis on a very quick note. Another capability which ArcGIS enables you with is spatiotemporal asset catalogs. So spatiotemporal asset catalog, or stack as we call it, is an infrastructure where you can store your data set on premises or on a cloud server or in a containerized Kubernetes environment. You can mosaic these images, add different raster from the container, and you can call using different metadata that you have structured using the Stack API or Python APIs in your resources. Moving on ahead, I'll show you one demonstration whereby you can see. So like Ishita already mentioned, how to create a, okay, give me a second. I'll share my screen quickly and we'll move to the demonstration. I hope my demo is visible. Thank you. So Ishita already reiterated how we can create a mosaic data set. So here I'll be in detail tell you about how we can create one raster mosaic data sets. So this is our very native interface of ArcGIS Pro, where we get many different ribbons and panes populated by different tool sets. So in the catalog where we have database, I'll just go in the database and I will click on new mosaic dataset. So here the beauty of this mosaic could be, this could be a multi-sensor mosaic as well and a single sensor mosaic as well. So it totally depends on our requirement, how we want to, what kind of mosaic dataset we want. It depends on the analysis process as well. Having a multi-sensor mosaic dataset, you can ingest many mosaics from the definition. You can see many different sensors and many different raster formats which could be ingested, be it optical images, be it hyperspectral image or SAR image. So all these raster dataset can be ingested. Once ingested and once created with the mosaic dataset, I can add different raster to my mosaic dataset from my localized environment. Here I can set if it is a multi-sensor raster, I can select the sensor capability, or I can select the sensor in order to make sure all the metadata get aligned in a structured manner, and I can create a band. Suppose I'm using Sentinel-2. I can ingest all the bands available in one tile. So I can ingest 10-meter resolution tile as well, 20-meter tile as well in the same raster dataset, and your raster dataset will look like this. Since this is a Sentinel image, I will like to brief on the data. This area is Vadodara, and other image tile is of Hyderabad. Further, I would like to take you to the stack, where how we can create a stack of our images which are available on the desktop and even on the cloud as well. So having connections, we should remember that stack needs one URL connection for cloud, like AWS storage or Azure blob. So having set the connection name and providing the connection link, we can create a direct connection, and your stack will look like this, and we can explore the stack in a manner where we can run we can find through different images of Landsat, of Sentinel, and even of knife, and different terrain data sets such as DEM and aspect and slope as well. Having a cloud stack, we can gives the larger availability of the data, or we can also configure the same stack on our environment, on our server, using the REST API of Python, where we can have our own stack which will look like this. And once we get into the scene, we will see how many dataset is available in the scene. This was my local stack which I have created with the dataset which are available with me. Once I zoom into this particular tile, I see a dataset which looks like this. This is a DEM. Having this DEM, I can go on and produce on-the-fly processing using the same dataset. Need not to change between different images, or need not to call images first and then do the analysis. Here I have not downloaded any image. I have just called it. I have called it from the stack, and I have run one raster function which is of aspect. So you can see on a simple click, it has produced me a single layer of output which is of aspect. This is the beauty of stack, where you can call in the raster on the fly and have one output in just few seconds. We will move further with the demo with the PPT slide and see on the additional capability. In the beginning, when I said that we are being poured with millions and billions of pixels every day, they are in high resolution, their sensor capability differ with each others, and they provide a very potent medium to analyze different aspects and phenomena that are happening over the surface of Earth. So ArcGIS Enterprise provides a platform to manage these large raster datasets or mosaic datasets in the form of hosted imagery or dynamic imagery, and you can produce different kinds of analytics using the raster function templates and different other environments like deep learning environments and many other power experience builder apps, web apps, where you can produce different kinds of results in order to analyze the surface of the Earth. We can deploy ArcGIS Enterprise on premises as well as on the cloud. So this is a standalone offering which you can utilize in order to do different kinds of image analysis on the web. So many imagery layers are different kinds of imagery layers are supported on the web. These layers are tiled imagery, or these are dynamic imagery. These hosted layers could be created through the desktop as well as from the enterprise or from the web itself. From the web, we just need to add the data from the desktop or from the online APIs which are available, online platforms which are available in the form of APIs. We can call in those data and do the raster analytics as I mentioned. Here, I will take a moment to brief upon the ArcGIS Living Atlas, which many of you might be aware of. But to reiterate upon, I will say that ArcGIS Living Atlas provides you with the thousands of data sets which are available for you for the analysis. These data sets are in the form of imagery, in the form of base map, in the form of feature maps. So there are many imagery layers such as spectral analysis layer, multidimensional layers, change detection layers, and all those layers are available for you to call upon and do the analytics. There are many Explorer apps as well. These Explorer apps are for Sentinel-2, where you can visualize the land use, land cover of the world, and different kinds of indices like water indice, like NDVI, and etc. on the fly on the simple click. You can also swipe between to see the changes which have occurred over the time on these web apps, which are called Sentinel-2 Explorer or Landsat Explorer or Sentinel-1 Explorer. So these are readily available to use from and to enjoy the benefit from on the Living Atlas, ArcGIS Living Atlas. So moving our focus on the web-based analysis, ArcGIS Enterprise allow us to do raster analytics on the web, where it provides us the capability to do many raster analytics using raster tools, using the raster templates, using raster functions. These processing are on the fly and produce a quick results and allows you to build a model and a template to call upon different modalities of images and to call data from different collections and different explorers. Let's see a quick demo on this capability which ArcGIS provides. So for the introductory purposes, this is how an ArcGIS Enterprise looks like. Here you see this is the home page, WebEx. You see a gallery. You can go to maps where you can create and do analytics. You can see your scene where you can do analytics on 3D data, 3D rasters. You can see notebook. Notebooks allows you to do a processing in Python. You can use your Python codes. You can see this content. So here you can see these contents. These are many contents which I have been working on this web. And what if I want to use any of this raster? There are hundreds of raster and hundreds of data sets. So what I can do, I can filter out these data set from layers. I can just click on the feature layers and it will only show me the hosted feature layers and the uploaded feature layers. So hosted feature layers are those feature layers which are available, which have been produced after the analytics which you have done on the web. So the base or the source imagery could be fetched in or could have been published by you. Even for the tile services, I can see there are many tile services available, which I have previously worked upon. And even for the imagery layers, you can see there are so many imagery layers. So this makes the cataloging and accessing and indexing my data on the web very quick and very easy. And this does not confuses me with the large data set as well. Once done with cataloging and moving ahead to the processing, what we need to do, we need to publish the data set. So I will go on to my content pane itself and I will click on to the new item where I can see I get a pop-up where I am called upon to publish a feature layer or from a URL, a tile layer or imagery layer, or many different functions are there which I can produce. So clicking on to the imagery layer, when I go, it asks me, what do you want to publish? So there are options. I have published a mosaic data set as well, which I will show you later in this session itself. I can publish image collection or multiple imagery altogether. But for the demonstration purpose for this session, I have published just single imagery and I will go to the next pane. You can see I have uploaded one imagery. This is Sentinel-2 image of Dal Lake, Srinagar. So I have selected my data set from my desktop itself and I have uploaded it. Here it will ask me about the names, tags, and summary about what kind of data set it is. These name and tags itself, these tags and summary itself help me with the cataloging and indexing of my data for the future. So these tags are extremely necessary when we publish the data. Moving ahead to the map viewer, where I can see where I have published this image, and we can see there are two images which I have published from my content. So here you can see that I have published these two images from my content. And what if I want to use ArcGIS Living Atlas to publish my content? So here I get all the layers, all the imagery layers which are available on the ArcGIS Living Atlas. Simply, I just want this area, images which contain this area only. So I will click on to show the content only in this map area. So I get all these layers which contains this area. So what I will do, I will add one terrain layer itself to showcase you how this function and this capability is very on the fly, and you can see map loading on a simple click itself. So you can see you just got a terrain layer automatically added within a few seconds, and this makes our processing very fast and our decision making on a very rapid manner. We can come to a conclusion and decision. Here again itself, we can do multiple filtering itself, and we can go on to the processing of processing of this data set. So you can see the transparency, you can see the visibility, you can see the timeline and custom parameters of these data set. Here are different fields where you can add filters, where you can add different layers, different passes, add data from different dates, end dates, etc. So that was the good capability. I'll just close this layer and remove this from this map, and we'll move on to the processing. So this is Srinagar Dal Lake, where I have used one raster function template. Initially, Ishita also showed one capability on desktop where she has used raster function template or RFT to identify the acid drainage in Damodar River Valley. So here again, I have used the raster function template. So these raster function templates, these templates are predefined. These raster function templates are predefined tools where you can just click on and provide your data set, and they will produce you for with a certain result. In these cases, for readily available or readily solution available templates, there are many templates available on ArcGIS Living Atlas as well, and on or you can customize your own template for your own purposes. These raster function templates allows you to automate your heavy processing tasks and streamline your processing and reduce and optimize the time and automate your work. So here for the same, I have used this template where I have called upon the algal bloom template, which you can see I have called upon from my content, which I just modified for the sake of the link. But you can also call upon many different raster functions available in different groups which people from the organizations share, or you can call upon these templates from online, ArcGIS Online, as well as from the Living Atlas. So there is no. So we will move on to the result of this template, where you can see the Dal Lake shows eutrophication. So this raster function template was for the algal bloom or water eutrophication, whereby it shows how much area have been occupied by the water hyacinth and algae in a freshwater body. This could these algal bloom could be of any reason, but it helps us and gives us insight where the polluted water is and what is the extent of this processing. So here with the result, I can see this north of the Dal Lake, there is very high concentration of algae and pollutant. So this gives me a very quick analysis and very quick report on this. So this was all done on the web environment, where I have not used the capability of my desktop, but of the server itself, where my enterprise has been hosted. So we will move on to the other demonstrations. So another product where we can analyze our images and our video in enterprise infrastructure is ArcGIS Excalibur. So ArcGIS Excaliburs provide you a cataloging capability where you can search your images, you can discover and access your different data set, which could be your image and videos. Here you can organize and share your project within your group and within your organization, where you all as a team or as a member can perform analytics and prepare interpretation report. So taking you quickly to ArcGIS Excalibur. So this is how Excalibur looks like, where you can do analysis, you can search between your different data sets, and you can connect to a web service using URL. Here you can publish different kinds of data set. These could be feature layers, these could be image data, or these could be video data. Even you can publish a live video here. and you can publish on-demand videos as well. For imagery layers, you can publish single imagery or image mosaics, and same as for the feature layers. So we will move on to the on-the-fly analysis used on image mosaic dataset. This is the same mosaic dataset which I produced. This contains image Sentinel-2 image of Vadodara and Hyderabad. The image is being loaded, where you can see there are two mosaic dataset layers available in this project. And for the analysis, we can swipe between and see between the changes which have occurred, and we can also compute and detect those changes using the functions of this tool. Here we can bring on to the raster templates. We can bring on to deep learning models to do certain kinds of analysis, identification of any object available in the scene. On addition, we can use screenshots. We can clip those images and we can prepare analysis report. So here you can see these two images. There are two images. We can just go on and we can swipe through the image layer. Here you can see for the Vadodara image tile, I am swiping between these tools. So this image shows how much area or how much built-up has been expanded in the Vadodara over the period of 5 years. So one image is of 2020 and the second image is of 2026. You can clearly see a difference, a visual difference, or I can say a visual interpretation using the swipe tool of this Excalibur. And you can move ahead and perform compute change or detect change. So for compute change, we have to just provide one primary layer and one secondary layer, and it will produce you with a change detection map where you can see where the highest change occurred and where the lowest change occurred. So the lowest change are the area where very few changes occurred. Similarly, in the analytics portion only, we can just clip on to the NDVI and we can get one quick NDVI of this area. Here, here we can just draw onto some area. And just select the images which you want. I have to just provide the red band, which is band 4, and infrared, which is band 5, and provide a folder to save my image, and we can get NDVI layer on a simple click. Here you can see the processing is being run on this server and not on my local machine. This will produce me one NDVI on these simple steps, which could be later added to analysis reports, and we can use the screenshot capability to have those images in the analysis report. Moving ahead to the video capability of Excalibur, here you can see we have one project where we have to inspect one facility. This video is of one industrial area where you see lots of infrastructure. And we can see how this area has been captured over here. We can use different tools to mark up, to count, and to measure different objects in the in the video frame, which will reflect on the base map of my project. So to add count up, here I can see this. Here I can see the images. Here the count up is. Here the count ups comes like this, and we can further create analysis report, and we can extract video frames as well for the report itself. So these were all the advanced capabilities of these softwares on the enterprise infrastructure, which is an ArcGIS Enterprise and ArcGIS Excalibur. In total, I will conclude this session. That was my last demonstration. And in conclusion, I will say today's session was filled with basic as well as advanced raster processing, where we saw change detection, classification, SAR analytics, as well as centralized imagery management, sharing, and accessing those data set in a secured manner on the server or on the cloud. We saw the capability and on-the-fly processing using Stack, and we used video analytics and raster analytics on the ArcGIS Excalibur. So these capabilities somehow sum up all the major advances and all the major tools and all the major capability which are available in ArcGIS Pro and ArcGIS Enterprise as well, where you can deploy it on your premise and on your server to do advanced raster processing. So this was all. I will thank you to attend this webinar session.